Hello everyone, welcome back to my SDL2 on Xcode series. In this tutorial project, we are going to build the classic snake game on Xcode using C and SDL2. This is episode 3. In this episode, we are going to explain what frame per second is and how it will affect our game. Now let's try to run our game first and see the current frame per second in our game. So let's move to this symbol here, and you can see here that the frame per second currently is 60. Why we have 60 frames per second? Well, if we come back to our code and let me stop our game now and go to the engine and look at the engine init default and look at the last line here. We set our engine to have the default FPS to be 60. What is FPS to be precise? Well, it means frames per second. It tells us how many frames per second we should run our game in our loop. So one frame means that one loop. If we're going to go to the event loop later, but before that, let's look at what it does in this engine set FPS. If we go to the definition, it basically checks whether it is less than or equal 0. If so, it will do nothing, and otherwise, it will change the current FPS to the input, and then we compute the time for each frame, because in 1 second we have 1000 milliseconds. So we will divide by the total number of frames, and that will give us the time per frame. Now let's see what it means by a frame. If we look at this event loop, we have a while loop that will go over and over until the someone asks us to exit the loop, right? And from here until here, that will be one loop inside our infinite loop. And this one loop is called one frame. And if we set the frame per second to 60, that means that in 1 second, we would like to run this loop 60 times. That is what I mean by frame per second. So how can we do that? The idea is that we compute the time we need to run for one loop. And if it is less than the time per frame, when we compute the average time per frame, then we will just delay a little bit of that, and then that will enforce we have the desired frame per second. To do so, we are going to use a function called SDL getTicks. If you look at the definition or summary, it said that it will get the number of milliseconds since the SDL library initialization. So this is in milliseconds, and that is the reason why in our definition of engine set FPS, we are going to use 1000 over the FPS. So now, and then that will get the timestamp, and then we will go through these 3 main functions to do our game. And then when we finish, that will actually finish one loop, and then we will get another timestamp again, and then minus the previous timestamp. That will give you the time we use in this frame. And if this time in this frame is less than the average time, then we are going to delay the rest of the time, and that will make sure that we have on average engine dock time per frame that long. But the problem is, if you look at this realization, you should realize that if, say, we run longer than expected, then this code will not run and will go back to here. And so this frame per second is just a upper bound. It will not guarantee you always get to that frame per second. For example, let me use some number to be more precise. For example, if we set our frame per second to be 60, then each frame takes up 60 milliseconds or so. Then if this piece of code run, say, only 6 milliseconds, then there was 10 milliseconds to spare. And here we use this delay function to take up 10 milliseconds. So in total, this loop will take up 16 milliseconds, and that is good because we maintaining our goal. However, if, say, this loops use up, say, 36 milliseconds, then it runs more than expected because we expect it runs within 16 milliseconds. Then this will not do anything and just keep running. So we cannot maintain 16 minutes for one frame because intrinsically this will run 36 milliseconds, and we cannot go back to the past. And that is the issue you should realize. Now, let's see what kind of different frameworks will affect our game. Let's go back to our main function, and we're going to add a little bit experimentation here. So let me set the engine set the frame per second to 1000, ridiculously high. Let's see what happens. Will it be 1000 for our game? Let's run it. So this basically means that we demand our game to run 1000 frames per second. So let's go to this here, and you can see that our game starts at 120 frames per second, meaning that our game here can only run as fast as 120 frames per second, even though I set it to be 1000 frames per second. But our hardware can only do that. So let's go back to our main function here and set it to be other values. But before that, let me go back to here and pay attention to the CPU usage. You can see that you use a lot of the CPU, around 50 or so. You can, and then let's and actually, do I have the average here? So you can see here, it seems that we don't have a average frame CPU usage. But then let me go back to the main.c files and set it to, say, 60 as our default, and see what is the difference. Right, let's go back to here and see. We now have 60 frames per second. So because our machine is fast enough to maintain this goal, so it will have a 60 frames per second for our loop. And you can see that the CPU usage is dramatically lower than 120. Now it only uses roughly 20% of the CPU than previously 50%. So lower frame per second will have lower requirement on the CPU. And that is especially important when you have a slower machine. Let's try to do something like 24. So that should use even less CPU. And let's go to here. You can see that we use now around, say, 10% of the CPU than 60, and we can maintain this 24 frames per second because our machine is fast enough. So you can see that using less frame per second will have a less resource demand. Is that the case where we should set it as low as possible? What happens if I set it extremely low? Well, then if you set it extremely low, then you will update your game in a less frequently, and that will have a laggy feel of your game. Let me try to do some extreme and set it to 1 and see what happens. So now if we go to here, you can see that we will have our game to maintain actually 1 frame per second, and the CPU usage is extremely low, and also we use less energy as well. However, the game here is less responsive. For example, if you click this close window, it will take a while to respond to your click. You can see that it will flows for a while and then exit. It is because if you set it to be 1 frame per second, then we have an interval of 1 second to update. So when you click the button, then it might wait at most 1 second to process your click. And that is the drawback of using low frame per second. Usually we will set this one to 60, or even 60 is enough actually for most of the game. But if your game requires, say, responsive, if your game try to be most responsive, then you will set this one to as high as possible, ridiculously high, and then you will let the machine decide how fast they can run. You can see here that if we set it 1000 and on my machine, it can only run up to 120. So let's see. So you can see that here now it will stabilize at 120. But using different frame per second will means that within each loop you have different time. So you have to be extremely careful when you try to update your game using different setup. For example, if you would like to be compatible within various machines, then you should not rely on this frame per second. In your update, as in here, you should not rely that one loop will take up exactly, say, 60 milliseconds if you set it to be 60 frames per second. You should consider the time elapsed when you update your scene. You should consider the time here as well. However, in our simple tutorial project, we are not going to worry too much about that. We are going to set our frame per second to be 60, and then we're going to go with that. But if you are going to develop your game on various platforms, then you need to pay special attention to this setting. That's pretty much it for this episode. Thank you for watching.